Okay, good morning, everyone. Greetings from Jakarta. Let me introduce myself first. My name is Nadila Shani. I'm research analyst working in ASEAN Center for Energy. Thank you for coming today in ASEAN Center for Energy webinar. I think this is the first webinar that we are conducting in 2020. And today's webinar, we will talk about waste to energy, solving the waste problem in ASEAN megacities. So let's just start. Okay, so before I will introduce you what ASEAN Center for Energy is. So we are actually the intergovernmental organization that is working under the ASEAN cooperation. We mainly focus on energy, and we have three roles to serve. First is think tank to identifying and surfacing innovative solution, and also energy data and knowledge hub, where we provide a knowledge repository for ASEAN member states, as well as the catalyst to unify and strengthen the ASEAN energy cooperation and integration. Among the works that we have done, we do research, publication, also high policy dialogue, policy exchange and recommendation, and also a secretariat of the energy cooperation. So in today's webinar, we target the audience to be energy regulators, policymakers on energy sector, energy researcher, academia, and also private sectors. So today we are conducting at 9 a.m. until 10:30 a.m. Jakarta time, which is unusual time. We usually conduct it in the afternoon after lunch, but now today we have the special collaboration with University Calgary. So we have to make it work. So we make it in the morning since the difference is 14 hours time. The expected outcome of this webinar is to encourage discussion on energy sectors, as well as provide information exchange and encourage a multi-stakeholder discussion platform. And today, the speakers, we have two speakers that is joining us. First is Dr. Zulfikar Yurnaidi. He is a senior officer of renewable energy and energy efficiency officer at ASEAN Center for Energy. And he got his PhD from Department of Energy Studies, Ajo University, where he also taught several classes. Prior to working in ACE, he has worked in Green Technology Center Korea, handling project of outline business case for waste to energy in Makassar and South Tangerang, Indonesia. And the second speakers will be Dr. Ganesh Dolwira Gamash. He is currently Director of Research of the Canadian Energy Research Institute, where he designs and executes research projects to assess economic, environmental, and social implications of technology and policy interventions with the Canadian energy system. He is also an instructor with the Sustainable Energy Development Graduate Program at the University of Calgary. So welcome, Dr. Ganesh, to this webinar. And also we have a colleague, Ivana Skendrovic. She is a partnership officer of the Extractive Resources Governance Program, or ERGP, School of Public Policy, University of Calgary. Also, warmest welcome for Ivana. So today's agenda, after the introduction, we'll proceed with the intro from University of Calgary, where Ivana will explain a bit about the program. And we will continue with the presentation of waste to energy potential in ASEAN by Dr. Zulfikar, and then continue with Dr. Ganesh Dolwira about waste to energy technology in Canada, best practices in solving waste problem in urban cities. Then we'll have a short question and answer So for all the attendees, we encourage you to write questions in the platform if you have any, and then I will ask it to our both speakers. And we are at the end, we are hoping to close this webinar not more than at 10:30. So without further ado, let's just start. I will hand the presenter to Ivana, where she will explain about the ERGP program.
Good morning, everyone. Thank you, Nadila, for your present introduction. And thank you, everyone, for accommodating the time of the webinar to our Canadian Calgary time. Greetings from Calgary. As Nadila said, I work for the School of Public Policy, the Extractive Resource Governance Program, and I wanted to provide a brief overview of our ERGP program. And let me begin by explaining where exactly we fit in within the University of Calgary. The University of Calgary is a fairly young university located in the western province of Canada, what we like to call the energy capital of Canada, the city of Calgary. The university has more than 250 undergraduate and graduate programs, and our School of Public Policy is just one of many faculties within the university. The school, which just recently celebrated its 10th anniversary, also tries to bridge the gap between academia, industry, and different levels of government to initiate discussions on the most emerging policy issues and trends of our country and globally. There are two main graduate programs. One is the Masters of Public Policy, and the second is Masters of Science in Sustainable Energy Development. And our presenter today, Dr. De Lovera, is our faculty member of the Sustainable Energy Development Program. There are four main research areas within the school, and our Extractive Resource Governance Program is somewhat unique research division within the school. The ERGP, in addition to conducting research on the extractive sector issues and trends, also works in collaboration with governments, with countries that have either newly developed or emerging extractive resources, and we help build capacity within these governments. We assist them with policy development and development of their regulatory frameworks of oil and gas and mining resources. Our expertise is in these three core areas: fiscal governance, regulation of oil and gas and mining operations, and public engagement and community consultation. Our expertise is based on the Canadian best practices and often best practices of international jurisdictions. Our courses are often delivered to senior ranking government officials or the individuals tasked with policy development. Our advice is always based on Canadian best practices, and it's based on transparent, efficient, and efficient policies, and regulatory frameworks based in Canada. Our services, our capacity building programs, can be delivered in different packaging ways, such as shorter courses, be that short webinar such as this one, or multi-day workshops which address specific issues identified by our client. We also offer a non-academic University of Calgary certificate course in three core areas that I have mentioned earlier. These are just some of the examples of the projects that we have either underway or just have recently completed. We have a very strong focus in Latin American region. We have done some work in both Africa and Asia, and are definitely looking forward to exploring more opportunities for collaboration with ASEAN member countries as well. If you would like more information on the School of Public Policy and especially the Extractive Resource Governance Program, I invite you to take a look at our website, and the link is provided at the bottom of this final slide here. Thank you for your attention.
Thank you, Ivana, for explaining the ERGP program.
Of course.
Now, I think we can move to the presentation and give the floor to Dr. Zulfikar. Yeah. Hi, good morning, Dr. Zulfikar.
Yeah, good morning, everybody. Hopefully you can see my screen clearly. Is it okay?
Yes.
Shani?
Yes, it's perfect. Yes.
All right.
You may start.
Yeah. Is it in full screen already?
Not yet. I think you should put it on full screen first.
All right, cool.
It's perfect.
Good morning, everybody. My name is Zulfikar. I'm a senior officer in ASEAN Center for Energy. And for the next 15 minutes, I will briefly share to you the potential status and challenges of waste to energy in ASEAN. Actually, this is an intersectoral issues. Although as an institution we focus on the energy issues, but we realize that the future of energy will be interlinked with many sectors, including environment, climate change, waste, as well as science and technology, transport, and many other sectors. So this is one of our efforts to promote energy agenda in ASEAN, as well as promoting intersectoral collaborations. So without further ado, I will start the presentation. So in general, the outline will be divided into three, actually four. The first one is the waste issue in ASEAN, as well as the potential of waste to energy. Followed with that, the status in ASEAN. I will bring up some recent news coming from some of ASEAN member states. And then we have to realize that although the waste to energy has a lot of potentials and many countries are currently pursuing such technology to be applied in their country, but there are various challenges which can be very specific to Asian countries which needs to be addressed. And actually after that there will be some additional slides related to the questions to be answered and what would be the potential roles of ACE to solve those challenges. We will start with the driver. The driver of the issues in both waste and also energy is coming from the growth, especially the population and economic growth, as well as urbanization. So the data shows that ASEAN population in 2017 is 642.1 million, approximately 8.5% of world population. But by 2040, it is expected to reach 782 million, and almost half of them, around half of them, will live in urban areas. The graph here also shows that for main megacities in ASEAN, such as Jakarta, Manila, Kuala Lumpur, the proportion of overall population living in megacity will be increasing, meaning that the urbanization rate will be getting higher even in the future. Second graph on the right hand side also show that in total in ASEAN there will be additional 70 million people to live in urban areas. Now, naturally, this will lead into the issue of waste because everybody, you and me, when we consume things, we usually produce waste, the things that we don't use in our consumption. It can come in form of organic waste, plastic waste, glass waste, and others. And we noticed that the waste generation in ASEAN countries is increasing quite a lot. And the left-hand side shows such related data. Actually, among ASEAN countries, Indonesia hold the first position in terms of waste generation. It is estimated that Indonesia generates around 64 million tons of waste per year, and it is followed by Thailand with 26.77 million tons per year, and Vietnam, Philippines, and Malaysia. The issue from the waste is that currently in most ASEAN countries, the waste management is done improperly. We have several illegal dumping, and actually the main waste treatment in ASEAN countries is in form of landfilling, mainly in open dumping. It's not even sanitary dumping, a sanitary landfill, which is probably the standard in developed countries. And I also highlighted several issues with that. First is this waste is normally not separated. There is a low recycling rate, and also there is unsafety in waste handling and disposal. This leads to environment concerns, including climate change, of course. In the left-hand side, I highlighted several issues. We call it, from economics point of view, is externality of waste. There is no real cost in it, but it actually provides some sort of damage to the environment, to the society. So it can cause health issues. It produces a lot of pollution, either in groundwater pollution coming from the acid leachate, the land pollution, which impacts the agriculture sector, the air pollution in form of odor, and especially it also contributes to the methane generation. Approximately in the global scale, 11% of methane generation coming from the landfill. Actually, it's coming from the organic waste decomposing in the landfill. It produces methane gas. Meanwhile, due to the climate change issues, a lot of countries, including ASEAN countries, already provided their nationally determined contributions, which aspires to reduce CO2 emissions in their respective countries. We can see like several targets in here, like Indonesia down by 29%, Cambodia down by 27%. And the issue of waste with its potential climate change impact might be relevant in the climate change discussion. On the other side, we also have issues in form of energy demand. The electricity demand keeps increasing. We can see in here that by 2017, the data on the left-hand side shows the electricity consumption by sector. By 2017, it is recorded that the consumption of electricity will reach 75,000 kTOE, and it will be keep increasing in the future, considering the rate of population and economic growth. There is a target coming from the ASEAN member states by individual countries as well as a regional target that want to make this energy generation and utilization in ASEAN to be more clean by two efforts, either by increasing the energy efficiency, but also by improving the renewable energy share. The target is actually regulated, governed by what we call in ASEAN the ASEAN Plan of Action for Energy Cooperation, or APAIC. And regionally, we have a target of reaching 23% of renewable energy share in TPS by 2025. And the right-hand side graph, the RE share in the TPS, actually shows the current status and the projected trend of RE share in the TPS produced by ACE through its Outlook series. We see that in AO5, ASEAN Energy Outlook 5 in 2015, the share of RE in TPS is around 13.6%. And in 2017, it increased a little bit to 14.3%. From there, there was several scenarios from AO5. We have BAU scenario, ATS scenario, APS scenario. ATS is considering the target of each individual ASEAN countries. APS by considering the APAIC target of 23%. We see it here that without any additional policy or BAU, the share of renewable energy in TPS by 2025 only reached 12.6%. Even with adding each individual country's target related to renewable energy, it will only reach 17.5%. So there is a huge gap currently observed in here from this target to the regional target of 23%. So while On the environment waste issue, we have the issue of waste. We also have another issue in energy sector, which is the need to satisfy the increasing energy demand, as well as increasing the share of renewable energy to reach the target, both individual country target and ASEAN as a region, as well as reducing the environmental impact and going through sustainable energy and sustainable development. So currently, we from AC waste to energy as an undertapped clean energy potential. As I discussed in extent before, the ASEAN is currently aiming to reach 23% of RE in its energy supply or TPS by 2025. However, the roles of MSW or municipal solid waste generation, or in other words, waste to energy, is currently still insignificant despite vast of potential it has, especially in its urban cities. Currently, there are only 4 countries reported from our database, the ASEAN Energy Database System or ADS, that have installed capacity of waste to energy. Thailand leads with 284 megawatt, followed by Singapore 256.8 megawatt, and there is a small portion coming from Malaysia 9 megawatt and Indonesia 15.7 megawatt. So out of the 14.3% RE share in ASEAN TPS by 2017, the graph that I showed you before, the MSW or waste to energy actually only accounts not more than 0.5%. So this fact actually shows that the waste to energy is still very untapped clean energy potential in ASEAN. If we go back a little bit to the data before, let's say that in Indonesia, it generates 64 million ton per year of waste divided by 365 days per year. And we can come up with maybe 100 or 200,000 ton per day. And some data from my previous experience working on the feasibility study of waste to energy. Usually 1,000 ton round that waste can be transformed into around 15 to 20 megawatt of electricity. So assuming the number I mentioned before, let's say 200,000 ton per day, we can generate around at least 2 gigawatt of electricity coming from waste of Indonesia alone. So those are some big untapped clean energy potential here. The next is I'm going to briefly show the status of each AMS or ASEAN member states regarding to waste to energy. A little bit of a highlight, we in ACE actually produced what we called news clipping. So we gather energy related news from the whole ASEAN member states and we compile it and we will put a brief story and then we will send it to the members of our news clipping list. So this also to promote that a little bit. So if you want to know energy related news in ASEAN, you can come to our website and register and you can get your weekly updates on ASEAN energy news on your email. So going into a little bit of the detail in Vietnam and Indonesia. So Vietnam actually still has, both countries still have limited waste to energy generation currently. But in Vietnam, especially in Ho Chi Minh City, they are trying to explore these options. There are currently 3 waste to energy projects approved in Ho Chi Minh City. It's still ongoing and we have to see whether it can be realized or not. In Indonesia, there is a very strong political will coming from the presidential regulation, which give 2 key incentives for waste to energy. The first one is the feed-in tariff, 13.35 cents per kilowatt hour, which is maybe doubled to the normal generation rate, generation cost in Indonesia, as well as support of tipping fee. Tipping fee is actually tax to waste processing. So the owner of the project can get this tipping fee from the government, and that regulation from Indonesia is giving another subsidy from central government to the local government. Unfortunately, it has been delayed. In a sense, it's not performed as well due to several reasons that I might highlight later. But this willingness is very strong from the country, and some cities like Surabaya or Surakarta, they are actually progressing very well. But for others, there are homeworks to be done. Cambodia is exploring currently for waste to energy alternatives, and they are seeking for private partner, but currently there is not yet a specific updates related to that, and also from the regulational perspective. Singapore and Thailand, as mentioned before, they are pretty ahead of the waste to energy. They have very high capacity, especially Singapore. They are widely known with their high level waste management system. Philippines, maybe some of you already heard about the Smoky Mountain in the Manila. It becomes a little bit of renowned because its issues in sweat management, it's very high, it's dirty, it's smelly, and it's causing problems to the citizens. So they are working very hard to push forward the waste to energy, but we still have to wait and see. Malaysia, similarly to that, they have an open tender for waste to energy management system currently. But due to some recent changes, we might need to see how well they push that agenda forward. So we come with the challenges now. Hopefully I can make it within the limited time. So the first one is, and the biggest one, is actually the poor waste composition. Basically, there is too much organic waste in Southeast Asian. It's the distinct characteristics of Southeast Asia. Usually in Europe, the proportion of plastic waste is actually higher. But Indonesia, Malaysia, Vietnam, Philippines, maybe 50 to 60% are coming from organic waste. The issue is the higher the water content, the lower the calorie. And because of that, the energy conversion in the waste to energy system will be very low, meaning when you cannot properly generate enough electricity, the revenue coming from the electricity sales will be lower too. On the other hand, it will create a high request of tipping fee to complement the sales of electricity sales, and this will lower the attractiveness of the waste to energy. So this is the big issues that should be addressed. The second one is the internalizing the externality. I explained to you before, there are a lot of negative externality related to waste, but not all of them is internalized, meaning people don't see the real cost of it. In Southeast Asia, you can just throw garbage in the streets, probably in the river. You probably make it nicely compacted in a plastic, but you don't really pay much. You don't care much where the waste go, what happened to it, as you only know it goes to the landfill, and you feel no obligation to pay for such management. That is called the negative externality. So we need to internalize it, and it's not realized yet. That's why governments are usually put several policy related to this, increasing the electricity cost by feed-in tariff, increasing the tax to be paid in terms of tipping fee, but generally it's not sufficient. So there are many things that can be done to do it, including guarantee, partial investment in infrastructure. Some policy in Indonesia is related to that, and grant for installation. The third one, which is February will be entered in this next session, is the technology options. There are a lot of options related to the waste to energy. One of the most famous one is actually incineration, is that you just burn the waste and produce electricity from the heat. But there are other options: pyrolysis, gasification, even plasma, the current status. But a question that should be answered before we choose this, whether it's proven in utility scale or it's only in the lab scale, whether it's suitable to the local condition. Again, the waste condition, the people, the socioeconomics, the regulation should be considered, whether it's commercially feasible, especially considering the low level of electricity price and tipping fee in the ASEAN countries, whether it's safe in terms of environmental and social risk. There are a lot of issues related to incineration, which actually halt the progress in Thailand and Indonesia. And what about the requirements of land, water, etc.? And the fourth one is what I like to propose is it needs to be some kind of integrated approach, change the behavior. This I mentioned before about waste separation, because it gonna improve the efficiency of the waste to energy, because if the waste you entered there has a high calorific value, meaning less organic content, then it will be more efficient. So you have to separate the waste somehow. But the sorting facility can go in the end, just before the waste to energy, in the middle, or from the source. The most optimum thing is actually the separation at source, which is happening in some developed countries. In Korea, it's a fully separated from source. In Japan and some Europe countries, it's probably done this way. But in Indonesia, it's very difficult and it needs very serious social engineering and, of course, strong regulation implementation. To conclude, these are the questions. Will it be possible that this waste to energy solve environment and energy issues in ASEAN megacities? Could it work with the current waste composition and waste management? How to make it economically feasible? Very important key. And what would be the most suitable technology? And how it can promote circular economy? I just put this slide here just to show that ACE will be very willing to assist the ASEAN member state to solve that from the perspective of clean energy generation. And as I mentioned before, we have 23% of share of renewable energy in the ASEAN, and we want this waste to energy to be part of it. So we have a very strong interest in this sector. And what we had in the past, we have a cooperation with Korean Energy Economics Institute, or KEI, basically on waste to energy and ecotown. So we noticed the issues to be addressed: landfill, the economic challenge, and energy. And what we propose is to make the town or city to be more eco-energy, an ecotown through waste to energy, which can help local residents, government, investor, and PLN, and make the city more green and more eco-friendly. We also identify several strategies that can be done, including promotion of local community, good financial proposal, thorough design, and collaboration with local government. The way forward well, it can be my personal point of view, but I do believe that waste to energy can be a part of solution to environment and energy issues in ASEAN megacities. And these are some activities, some proposed programs that can be done to, again, answer the questions before related to the waste composition. There are many things that we can do. We can do some study of appropriate policies and technologies. There are options. Pre-treatment can really help to increase the calorific value of the waste. Bio-drying and new technologies can be used to dry, to take out the moisture and water content from the waste before it fed into the waste to energy. We need some pilot and upscale of already available separation at source policy and strong public awareness program. Related to the economic feasibility, we need very strong capacity building on waste to energy co-benefits to make policymakers realize how useful is a waste to energy. Again, to internalize the externality. We need technical support on incentive policies and the risking mechanism on the financing. Related to technology, ACE is open to collaborate, maybe with Calgary or any other institutions, to make a strategic report doing comparative studies of suitable technologies, of course, tailored to the distinct, unique characteristics of ASEAN megacities. And then based on that, we can help on the capacity building on technological options. And related to the making it more integrated approach, we have to promote again 3R policies: reduce, reuse, recycle. And the second one is what I think very important, which is the waste type-wise treatment. Meaning that once we can properly separate the waste, we have to make separate treatment for organic as well as the non-organic or combustible. So the combustible can go to waste to energy facility incineration, for example, while the organic part can go to several technologies like biogas or composting or others. These also can help to make people change its behavior to separate waste. And also, other than that, we will need intersectoral collaborations and community built up. So those are my presentations. I think I'm 5 minutes over. Apologize for that. Thank you, and waiting to hear the feedback and questions from you.
Thank you so much, Dr. Zulfikar, for appointing the challenges and the problems of waste in related to the energy in ASEAN megacities. I think we are well timed and well aware now what is the problem and what are the steps that we can do for ASEAN megacities in order to resolve this problem. So let's hear another perspective from maybe the best practices that is done in Canada from Dr. Ganesh. So Dr. Ganesh, the time is yours. Dr. Ganesh, can you first unmute your microphone? We can see you, but we cannot hear you. Yeah. Yeah. Can you try to speak?
Yeah. How about now?
Yeah. Yeah. Yes, we can hear you now.
Excellent. Thank you, Nadila, and thank you, Dr. Zulfikar, for an excellent presentation. And first of all, thank you for having me as a speaker in this session. Really honored to be here. I also want to thank School of Public Policy for coordinating from our end. As Nadila mentioned, we are about 14 hours behind your time. So good morning, everyone. But it is late in the evening for us. So what I'm going to do in my presentation, what I am going to do is touch on waste to energy and other waste management options that is being tried, pursued in Canada. As Nadila introduced, I am actually with the Canadian Energy Research Institute. That's my primary research. That's where I conduct my primary research work, and I also work teach at the University of Calgary, Sustainable Energy Development Program. Before I get going with my presentation, I just want to take a minute to introduce my institute, the Canadian Energy Research Institute. My institute was founded around 1995, so we've been around for almost 45 years. So we are celebrating our 45th anniversary this year. We are a not-for-profit, independent energy research institute. We look at various different aspects of Canadian energy systems. Everything from oil and gas extraction to electricity generation to end-use services, industrial and residential and commercial energy consumption issues, and we conduct energy analysis, and then that will be followed by energy economic analysis, both at a micro level, to provide insights for companies, agencies, as well as we also conduct macroeconomic assessments to provide some insights or policy support, to policy relevant analysis for the government and policymakers. We also conduct publish several publications. Some are monthly publications and then some are quarterly publications. Like I mentioned, we are a public institute, so all our studies are available in the public domain. You can access all those studies through our website. I believe I have listed the website at the end of my presentation on the last slide. So with that, I want to first start with this would be the outline of my presentation. I'm just going to start with a brief introduction of waste management issues, or the how much energy we produce in Canada, and a little bit of background there. And then I'm going to touch on what are the waste management options we have. Obviously, the session is about waste to energy conversions. I'm going to cover waste to energy conversions, as well as some other options. A brief introduction, of waste to energy economics. What's the economic situation? How do they compare against their competition in terms of as an energy source? And then also, touch on some options and policy tools one can use, or jurisdictions, countries can use to promote waste to energy conversions. And then I'll finish with some concluding remarks. Whenever I cover some of the management options, I will take examples, case examples from Canada, actual project examples, as well as some of the policy tools or policy instruments we are using to support waste to energy. Here I am showing, per capita in a waste production, both diverted waste. This is where we would divert waste into some kind of processing, recycling or reuse processing, and then and also undiverted or disposal. The waste that we actually dispose into generally landfills. So the dark brown slice actually shows the diverted energy. Undiverted energy, or what we dispose. Both majority of that waste actually comes from non-residential sources. These are basically businesses and institutions. And then about 50% of that actually comes from residential sources. And as you can see, it had gone up and down. Around 2008-2010 period, there was a little bit of a decline, but this is very likely due to the economic crisis, economic downturn around that time. If you look at per capita waste generation, we emit around 700 kilograms per person per year. Now, that is actually quite high compared to some other countries. Compared to other countries in the world, that is actually in the high side. Like one positive story is between since like early 2000s, starting from 2002 to date, diversion rates actually have increased. Actually, it has from 2002 to 2016. It actually has increased by almost 40%. And if you look at the diversions again, residential diversion is actually quite higher, around 31%. compared to non-residential diversions. By diversion, as I said, I mean recycling and reuse programs. So in terms of solid waste disposal, obviously landfills are the primary means for the disposal of waste, undiverted waste, solid waste. In the country, around, I mean, it is a big country. We by land mass, we are the second largest land mass on Earth. I mean, the country with the second largest landmass. We have about 2,400 landfills of varying sizes, depending on where they are located. Different sizes of landfills, all around the country. In addition to landfilling, there's some incineration. This is basically, just burn the waste, not dump it in a landfill or like dispose into a landfill, but incinerate. And then some incinerators actually do have energy conversions. There are about 10 to 12 active incinerators around the country. About 6 of them actually do have energy recovery. Waste collection and disposal is generally well managed and operated. I mean, we don't feel like we have a waste problem. It is well managed. Illegal dumping is not an issue. It happens in a very orderly manner. So there's both public and private sector participation. In terms of public participation, this is primarily municipalities. Mostly waste collection is done by, especially residential, from residential customers, so from households. Waste collection is primarily done by municipalities, public, but there's some private sector participation as well in terms of waste collection and management. Again, we are not any different from ASEAN countries. Landfill gas emissions is one of the biggest issues. And then there is actually from landfills, landfill gas emissions is actually one of the biggest issues, and there is a source of greenhouse gas emissions. And obviously, the order near the landfills is also an issue. And the other issue is, leachates. In landfills, collection and treatment need to be done in order to, avoid groundwater contamination. So if it is not properly managed, there's room for groundwater contamination. So those are the primary environmental issues that is gaining attention all around the country. Now, as I mentioned here, greenhouse gas emissions, from landfills is actually, one of the environmental issues. And here I am actually showing, total greenhouse gas emissions from landfills, from waste management, actually, from the waste system all around the country. So it is around 20 million metric tons of carbon dioxide equivalent per year. To put that into perspective, that's about 3% of national greenhouse gas emissions. Now, and then obviously, this is primarily due to methane emissions from landfills, the methane associated with landfill gas, that comes out of, unmanaged landfills. Now, 3% may sound, not that, high and big of a number. 3% is a fairly small number, but the concerning factor is it is not changing. It stays around that 20 million tons. Or 3% of national greenhouse gas emissions. Since 1990, we haven't changed too much. that means, there's still a lot to do in terms of, I mean, that means, we still have landfill, like unmanaged landfills, that is emitting landfill gas, which could potentially be, maybe captured for a useful purpose. So this shows, although it is a small number, it is not changing. It is staying as a stable number, and there's some variability year to year, but it stays around 20 million metric tons. So all in all, we actually have a kind of a dirty secret. So Canada is, usually, we don't feel like we have a waste problem. It is a very big and open and a very like a beautiful country. But due to like a high consumption, we actually do produce a lot of waste. On per capita basis, Canada is one of the highest waste producers. And in fact, in some years, around like 2008, 2007 period, we were actually, the highest emitter per capita, in all of the OECD countries. So we do have a waste problem. And like I mentioned in my previous slide, status quo is not sustainable. And so this had actually gained attention of government policymakers. So all federal all levels of government, whether it is federal, provincial, or municipal level governments, everyone is actually taking action to pursue different waste management options. Now, in terms of greenhouse gas emissions, all the actions that Canada is taking are actually guided by Pan-Canadian framework for clean growth and climate change. And some of the policy instruments that I'll be showing that in my presentation are actually guided by are initiated by the Pan-Canadian framework. So here I'm actually showing some of the waste management options. Some options deal with municipal solid waste. So I mean the main option, the obvious option is landfilling. But then there are landfilling can be many different kinds. So you can actually do some energy recovery, or there may be some energy recovery. By energy recovery, I mean primarily landfill gas recovery or collection. But then there are most landfills you have ones without energy recovery or gas recovery. And then of that, there are, unsustainable landfills, what we call the dry bomb, they take, so long, for the material to, completely degrade. So very slow degradation. And then there's sustainable landfills, even without energy recovery. And then I will actually come into explain these in a bit detail. Some of the actions, some of the efforts that are being taken in Canada. And then you can also do energy recovery from landfills, primarily landfill gas. And then in case of both, and they definitely fall under what you call sustainable landfills. You recover energy, and then you take action to speed up the degradation, and then you can do some material and material recovery and reclaim the land. Maybe build another landfill, or for other developments. And then in the other two options we have, the other two categories options we have, like a biochemical conversions, things like you can convert them into biogas, or you can take biochemical conversions to produce liquid fuels. You can also produce compost. Composting is quite popular, in many Canadian municipalities. You can also, take some, biochemical conversions to produce some high-value chemicals. And then you have thermal conversions. You can convert. You can take some do thermal conversions of municipal solid waste to produce electricity, heat, or some liquid fuels. And then popular thermal conversions are incineration, gasification, and pyrolysis, like Dr. Sulfika actually mentioned. Next slide. So if you look at alternative landfill options, when we started actually building landfills, they used to be what we call the dry tomb landfills. So first generation landfills are just dump it, dispose the waste into the landfill. Those are very large anaerobic bioreactors. It degrades very slowly because it is covered. It keeps the water away. And again, because if it, and there's no you have to the landfill will over the years it will collect leachate. The second generation is what you call the bioreactor landfills, so waste cells. There we have some active interventions. So there could be recirculation of leachate, and in order to get some rapid degradation, to get rapid degradation rates, and then you can also add gas recovery. From to produce energy, and then and so bioreactor cells are anaerobic landfills. As a third generation sustainable landfills or waste cells, they are we actually have a sequential anaerobic and anaerobic operation. And you can also do some mining to recover metals and other reusable materials, primarily metals actually. So like I mentioned, you start with anaerobic operation, operate in anaerobic mode in case of sustainable biocell. Operate that in anaerobic mode for about for few years, while energy recovery is viable or gas recovery is viable, and then operates under aerobic conditions during the second phase for faster stabilization to let the ground stabilize faster. And then you can also do mine the landfill to recover material. This is actually one. So there's a biocell project that is being that has been implemented in Calgary, where we are based in. This project has been initiated by University of Calgary in collaboration with a local engineering firm and the city of Calgary. And then I'm actually showing some of the pictures. This was the construction started in 2004, and so it is still operating in anaerobic form, meaning there's leachate and gas collection. I mean, there's still gas recovery from the biocell. So it hasn't gone into the next stage yet. But that is the plan. That is the plan, for this land cell, for this biocell. And there's another one in the planning stage. If you want further information, I have provided the link. University of Calgary project website where you can get some further information. So that is some I should say none of these new like alternative landfill options or landfill management options are necessarily new. I mean, we know how to do that. These have been sustainable landfills are being operated by many countries for a very long for a very long period. So it is definitely doable, with proper government and public action. We can do this. We can implement them and then operate them sustainably. I want to go into energy conversions. The other option, the energy conversions. So I'm actually looking at municipal solid waste to electricity conversion options. Again, there's a landfill connection. You can collect landfill gas from the landfill, and then you can convert them into electricity. Sometimes electricity, or even sometimes in cogeneration mode, where you actually produce both electricity and heat using internal combustion engines. Just burn the landfill gas in an internal combustion engine, or you can also use gas turbines. The other option is, we start with municipal solid waste and then incinerate and then operate a steam turbine, and then produce electricity and or electricity and heat, or you can actually gasify it, and then again gasify, produce a gaseous fuel, and then operate engines or turbines. Like another method is, we use municipal solid waste in a like a AD or anaerobic digester, produce biogas, and then operate heat, IC or engines or turbines to produce electricity and heat. The choice of the technology, is primarily comes down to cost, and then what are the conditions you have, types of municipal solid waste you have. And again, it is primarily driven by local conditions and economics, the cost of this middle, direct from municipal solid waste to direct electricity conversions. The most common one is incineration with steam turbines. Like I said, again, none of the technologies that I showed are actually new or proprietary technologies. Those are very mature commercial technologies. Anyone can actually do. There are developers. I am confident in any country, you can find an engineering contractor to develop any of those technologies, or implement any of those technologies. In Canada, there are about 6 waste incinerators, like I mentioned before, with energy production. But I should say none, has been built since 1990s. Especially in large scale. No incinerators with energy recovery, energy conversions has been built since 1990s. There are several small scale landfill gas to electricity generation projects all over the country, in almost all provinces. They're quite small. They are around like a 1 megawatt range. They are mostly built with financial support provided by different governments. Like I mentioned, some of those assistance came through Canada's Climate Action Plan. Here I'm actually showing one of the largest incinerators in Canada. This is the Burnaby incinerator in our westernmost province, British Columbia. The incinerator actually receives municipal solid waste from Vancouver. Vancouver is the largest city in BC, the 4th largest city in Canada. The plant was built in 1988. It processes about 300,000 tons of municipal solid waste, and it produces about 150 70,000 megawatt hours of electricity per year, and it also produces some steam. So it actually operates in cogeneration mode, and then it also has some metal recovery from the remaining. And here I'm actually showing one of those more recently built small landfill gas to electricity converters. So this is based in Regina in Saskatchewan. So Saskatchewan is actually like another western province in Canada. So it started operation in 2017. And then it produces about 2.6 gigawatt hours of electricity per year. It uses internal combustion based system. It actually received this. I should emphasize, here you have, you can actually build this type of projects, as long as you have a guarantee that you can actually sell this electricity to someone. So it actually received a long-term power purchase agreement with SaskPower, which is the provincial electric utility. The project costs was about $5 million to implement the project. It was built by the city of Regina, and the city would be able to, by through power sales, it would be able to, the revenue would be about $1 million per year. And then in 2019, the city actually received a grant from the federal government through the federal government's low carbon economy fund to actually drill a few more recovery wells so that more gas can be diverted, like a landfill gas can be diverted into this plant. And then, I mean, like I said, there was just one plant. There are many more that are being considered or being constructed all over the country, even in Canada, even in Calgary. So Calgary received actually another grant from the federal government through the from the same fund that I mentioned before, to drill some of the landfills within the city for gas recovery. So after that, I want to show some economics. What does it actually cost to show some of this, to touch on some of the challenges they have. Now, like I mentioned, these are all, like a well-intended, projects, in order to deal with like ongoing issue of, dealing with solid waste within municipalities. Those projects have been implemented, but we don't see very many of them coming. I mean, the actual, although there's potential, like Dr. Zulfikar mentioned, there's a lot of potential. I mean, we generate a lot of waste, but we are not seeing many waste to energy conversion projects. One reason is actually here I'm actually showing, what is the levelized cost, so average cost of electricity produced by some of the municipal solid waste to electricity conversion technology. So here I'm showing, incineration with steam turbine, the most common one, or to gasification based systems. And then the cost of electricity produced by them is around 15 to 27 cents per kilowatt hour, in Canadian cents per kilowatt hour. If you compare that with other competing technologies, their competition, like natural gas combined cycle gas, gas turbines, that's about 5 cents. And then if you look at other renewables like wind can also be around, there's a lot of good wind resources in all over Canada, and the capital cost of wind has declined significantly. And average cost of wind again would be around 5 cents per kilowatt hour. So if you just compare, if you look at the economic cost differential, it is very difficult for landfill. I mean, so from municipal solid waste to electricity conversions to compete with other competing technologies. like I said, cost of electricity produced is relatively high, and other competing technologies, like another thing I should have mentioned is, natural gas price in all over North America has actually has been quite low lately. Over the last 10 to 15 years, it has been about last 10 years, I should say. It has been on like a very low side. We produce a lot of natural gas, and natural gas with combined cycle, natural gas, fired combined cycle gas turbines actually has become the least cost option for power generation in almost all of North America. And then I believe, my understanding is in many other countries as well. And then, capital cost of other renewables are also declining rapidly, making, the cost of, making it difficult for waste to energy converters to compete. Now, I don't want to, be, too pessimistic about it. And, that's obviously, how can we make it work? Here, the electricity cost may be too high, but we may want to do these conversions not just to, like, electricity could be just the byproduct. The actual value we are getting is actually, managing the waste problem. So if that is our thinking, if that is our objective, there are ways to actually, promote, or lower the cost of, municipal solid waste to electricity conversions. So you can actually obviously provide, direct financial support, but it may not be long-term, sustainable in the long term. And then there are some other indirect options, like many provinces actually have renewable portfolio standards, meaning utilities must source a certain fraction of their electricity from renewable sources, and solid waste to municipal solid waste to electricity conversions are eligible for renewable portfolio standards. There's carbon credits or carbon pricing which can make municipal solid waste competitive against natural gas. It will help, I should say, but it will, it will be still difficult to compete with natural gas conversion unless the carbon price is very, 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 very high. I'm thinking, even over $200 per ton of CO2. Like another way, we can help or incentivize, waste to electricity converters is actually, through power purchase agreements. In Canada, all clean energy projects actually can receive an investment tax credit. Under Canadian, fiscal regulations, they can, receive investment tax credits, which will allow waste to electricity converters to, if it is a private investment, they can actually depreciate the capital investment in an accelerated manner, saving some corporate tax. And then that way we can actually reduce the cost of production by about 10 to 15%, depending on the technology. But still, it's still not enough, not sufficient to compete with other options. In interest of time, I will skip some of the discussion here. Oh, I should say, actually, another option is, rather than building dedicated, waste to electricity converters, we can actually do co-firing. And then there are some, efforts that are being taken in city of Calgary, to divert some of the, landfill gas recovered into a natural gas-fired power plant. So it can actually be co-fired with some clean. It can be co-fired with natural gas, or if it is solid waste, you can actually co-fire with coal if there is a coal-fired power plant that can take it. And then you can also use, rather than just producing electricity, we can also produce, thermal energy or heat. Like one potential opportunity is actually cement industry, because cement production is a very energy-intensive operation. Kilns need, cement kilns need a lot of energy, and municipal solid waste can be actually used as a as an alternative energy source for the kilns. In Quebec, one of the provinces in Canada, municipal solid waste fraction in cement kilns is about 34%, which is relatively high. But then there are other countries, where it can be as high as 50 to 60%. Like another option is municipal solid waste to chemical conversions. You can actually gasify the solid waste, produce syngas, and then run some chemical conversions to produce high value chemicals or liquid fuels. And again, in Alberta, in our province, there is a commercial project that is in operation since 2017 in the city of Edmonton, the provincial capital city. So it is an initiative by the city of Edmonton, the commercial operator NRCam, and Alberta Innovates, the provincial, kind of like a lab system, or the technology research institute, or technology, developer. The plant is operated by NRCam Alberta Biofuels, and the cost of the facility was about $120 million, but the actual fuel converter costed about $80 million, and then it was partially funded by the province of Alberta. And the facility actually plans to produce about 100,000 tons, process about 100,000 tons of municipal solid waste annually, and it has the capacity to produce about 38 million liters of of biofuels. The main biofuel it produces is actually ethanol. So it has the potential, it has the capacity to produce about 38 million liters of ethanol per year. And then Canada is actually in the process of implementing a low carbon fuel standard, so that can actually provide like a higher business opportunities. The value of biofuels produced by ethanol produced by this plant will be more valuable, even more valuable, when a low carbon fuel standard is implemented and in operation. So like I said, there's like another conversion option, which is under like another facility that is under operation in Canada. So a few concluding remarks. Waste to energy conversion can actually contribute to sustainable waste management. In this country, many of those options are actually being pursued. We don't have a whole lot, but many are being pursued. And the main challenge is land, like I said, is it's the primary challenge is actually the economics, because landfilling is cheap, and then energy in North America, and then especially in Canada, is actually relatively cheap. And then public and climate policies can actually help to promote these things. But like I said, it may not be a direct carbon pricing, which can also help. But we have to find some creative approaches. Things like renewable portfolio standards, or provide a higher value for biofuels produced by waste processing. In some cases, actually, local factors may lead to better economics. I mean, in some provinces, actually, they may not have. At least 2 provinces do not have natural gas supply in large scale. So in those cases, actually, economics may be different. So those are actually potential low-hanging fruits. Like another one is direct thermal conversions, like cement production. Those may be low-hanging fruits. So we have to pursue all of them. And then those sustainable landfill options they're gonna inevitably they're gonna help. I mean, like I said, those are not not a new concept, and then we know how to do it. We just need the we have to take the initiatives to do them. And then it is a big problem. Waste and climate problem, they are related. I mean, they could be related, and then in order to solve those things, we need all the tools. It's not just waste to energy. We have to pursue all our options, all the technology options we have. So that actually concludes my presentation, and and thank you for your time. And then I'm more than happy to take your questions. Here, I have actually listed, my institution's, website where you can actually, access some of the studies we have produced, over the last few years. Thank you very much.
Thank you, Dr. Ganesh, for sharing about the waste to energy in Canada. I take notes that there is quite interesting points that you raise, especially that Canada is also experiencing waste problems, not in terms of the waste management, but in terms of how big the emission it emits from its landfill. I think I learned that just today. And also about the LCOE of the waste to energy plants. It struck me that waste to energy is one of the maybe most expensive compared to the other resource. And I think
That
that's
is an observation. Yeah.
Yes, and that leads to the economic parts of it. That we think the solution of the waste problem, we also needs to think not about only the technology but also the economic point of view of it. So
absolutely.
Thank you so much for
yeah.
Yes, thank you so much for stating the facts and the knowledge. Now we actually received quite a lot of questions from the attendees, but since we are have limited time, maybe I will just ask two questions from the attendees. And before that, I will also need to convey to all the attendees that we will actually upload this webinar session and share the presentations of both Dr. Zulfikar and Dr. Ganesh and also Ivana at our YouTube channel. So after the webinar, you will can access it further. So let's just start with the questions. So the first questions is about from Melati Wulandari. Her questions is asking about the CO2 emission aspect. Her question is, what about the CO2 emission aspect, especially from incineration as one of the most popular MSW technology in ASEAN countries? Is it proven to be lower than the other fossil fuel plants? Maybe Dr. Ganesh could answer this first, and then maybe
so
Dr.
yeah, I can take a stab at it. So the main thing, I mean, it does produce. I mean, obviously, if you burn anything, it's gonna produce CO2. But here the thinking is, the base what we burn is actually it's not fossil fuel. So it is the waste we produce. We have the waste that got burned inside in waste to like in an incinerator is actually in a closed carbon cycle. I mean in like a seasonal so they get recycled back to plant tissues in years, not like generations or hundreds of years. So yeah, it produces CO2, but that CO2 is actually the source of those CO2 that CO2 is actually plant matter, and then in the next growing cycle the plant will absorb that back. So it is in a closed carbon cycle. So that is the rationale to pursue waste to energy conversion or incineration as a CO2 mitigation option. The other side is if you let it just degrade on a landfill, it's gonna emit methane which has a very high global warming potential. It's something like 25 times CO2. So the net effect is you get a net CO2 reduction.
Okay, thank you, Dr. Ganesh, for the answer. Dr. Zulfikar, you want to add on that or not?
Yeah.
Yeah.
Proxy answer. So adding to the answer from Dr. Ganesh, so basically, yeah, the methane the avoided methane emission coming from landfill, if we compare it to the CO2 emission from the waste to energy, is actually, how can I say, it will be more efficient in the sense that the CO2 emission coming from the waste to energy will be less than the potential methane emission coming from landfill. As a proxy answer, if you have heard about the clean development mechanism, so this is one part of the protocol that you can get certificate for CO2 emission reduction projects, and actually waste to energy is included. So there are some library of methodologies to do the calculation. If you check in the CDM website, they can calculate clearly the difference or CO2 emission reduction from landfilling compared to the waste to energy. Thank you.
Okay. Thank you for Dr. Zulfikar adding it the answer to the questions. Now the second questions, it's related to some policies. It's from Valia Serifalsatid, if I mention it correctly. So the question is, how can we implement PPP or polluter pays principle in ASEAN? Or if I can point to the Dr. Ganesh slides, in Canada we are actually seeing carbon taxing for encouraging the waste to energy implementation, and how, if I may ask, how effective is that to encourage the implementation of waste to energy compared to the other policies like direct incentive or FIT or the other like RPS?
I can start again. So
Yes.
the most carbon pricing policies actually, at the actual direct pricing actually started very recently, relatively recently. So I do not have like a evidence to do a full comparison. But some provinces like Alberta, we have had several direct and indirect carbon pricing mechanisms operating since 2007, actually for a very long time period. So how they have helped waste to energy conversion efforts is actually the polluters, those who emit CO2, primarily like industrial emitters, would pay the carbon price, and then that actually goes into a provincially managed fund. It's actually that fund that will help out, provide some incentives and then financing help. For example, that waste to ethanol production facility in Edmonton. The partial funding came from the carbon pricing system or the carbon fund.
Okay, thank you, Dr. Ganesh, for sharing it. And Dr. Zulfikar, you may want to add on that.
Yeah. So polluter pay principle is a very important policy aspect to solve waste issues. In Indonesia, as I mentioned, it's very weak currently because the flow of fund from the citizens to the government and then to the project developer of waste to energy is very low and inefficient. And but it can be very difficult to do that because again we don't In Southeast Asia, probably we don't really feel the obligation to pay for that. And similar thing happened in Bhutan. Last time I visited there, we also proposed a similar principle, and they were confused because basically they don't even pay for school and health. Why do they have to pay for the waste treatment? And this caused an imbalance in terms of waste treatment. If there is no money in general coming from it, then nobody will get to solve the problem, and they have to expect other revenue to solve it. And that probably another cause of low implementation of waste to energy in Southeast Asian countries. One good example of this polluter pay principle is actually coming from Korea, and they actually spend maybe 20 years to push that. What they do is it's a follow. When they discharge waste, they have to pay it based on the volume. Again, they have a very nice separation at source system. So like if you throw garbage, organic waste, you have to put it in specific plastic bag and you have to pay for it. Basically, you buy plastic bags. The same for combustible waste. You have to buy for the plastics based on volume. If you throw some big size waste, like in my case, when I moved back to here, I have to throw a lot of cabinets and beds, mattresses. I have to pay for it, for each of it. And you don't have to pay only for recyclables like plastics and cans, because those recyclables is actually gathered by private companies who made money from it. So we see here, when you solve the waste management issue in an integrated approach, as I mentioned before, like each part of it can be monetized in a sense, then the market will automatically solve the issue somehow. And for some waste that have no value, like combustible organic, currently the polluter pay principle is required. It's very difficult in a sense, but we can learn from experience from countries of how to do it well. And my proposition is by actually doing some pilot, small cities or some areas of cities, to see the willingness of the people to change the behavior, to introduce proper treatment, to ensure that when they separate the waste, it does treated separately. Because some issues I faced in the field is that they feel even though they separate organic waste and the other waste, it ends up together in the landfill anyway. So there is no use for them to separate. So they only do it in the beginning diligently, but in the end they just throw it together. So this kind of social behavior and regulation is required if we want to implement a proper PPP in Indonesia or any other Southeast Asian country. Thank you.
Okay, thank you so much for the interesting answer, Dr. Zulfikar. I'm afraid that we need to really wrap up this webinar because we are actually out of time. I would like to thank Dr. Ganesh, Dr. Zulfikar, Ivana, as well as the Canada to ASEAN missions for collaborating and jointly held this webinar. Thank you so much for your contribution. And I would like to thank as well all of the attendees that is joining us this morning. We have a full room until now, actually, so I really appreciate it. And I apologize for all the questions that is not yet answered. We will share the PPT and the slides of both speakers. And if you may want to ask further questions, please approach us or approach both of the speakers if it's allowable. Yeah, I think that's all. Thank you all for today's webinar. I hope that we have a very productive discussion. And as we are in Jakarta and now in Calgary is also working from home due to the COVID outbreak, we hope everyone to be safe and stay healthy. Thank you.
Thank you.
Yeah, bye.
Bye, thank you.